we look forward to your presentation. Thank you so much for being with us.
Well, thanks for the nice introduction. My name is Schütz-Trilling. I work at Surfix. Surfix is situated in Wageningen in the Netherlands, and I work there since 2013. And I'm now in the role of a team lead for the assay development team. And today I'd like to tell you something about our technology with the title Pioneering Photonic Solutions to Revolutionize Early Diagnostics. At Surfix, our mission is to advance global health, and we want to do this by addressing the critical gap of diagnostic testing. Therefore, we focus on delivering solutions that are accurate so that you can reliably detect the disease, that are accessible so that also unserved areas can benefit from it, and that are affordable because we believe that cost should never be a barrier for diagnostic. And we are quite apart in our focus since we are focusing on currently unserved point-of-care testing segments. These are areas where existing diagnostic tools either don't reach or aren't effective. And by targeting these unmet needs, we are not just improving individual outcome, but we also believe to contribute to a stronger public health system worldwide. So we want to do this by delivering accessible testing with fast results. And we have two parts for this. We have a cartridge with the biochip in it, and we have a small benchtop device that is the readout. And benchtop is quite nice for point of care. And it's also important because 70% of today's medical decisions still depend on laboratory test results. So with we can measure at lab level precision, and we can detect proteins in the picogram range. Our device can measure up to 5 biomarkers in one test with a high accuracy, and it's multiplexing to improve the outcome of the test, of the diagnosis. And we believe that's a strong point because current tests are mainly based still on one biomarker. If you then look how long it takes to get a laboratory test result back, it's an average of 3 days of waiting time, and we can speed up the time by a factor of about 300 because we are targeting a time to result of 15 minutes. So this makes the decision making quite convenient because it's way faster. And we estimate that we can reduce the cost price when we use very high volumes. So we believe that these kind of possibilities, and especially the sensitivity that we can target, will unlock the market segments for point of care. As already mentioned, we are focusing currently on proteins, so on immunoassay, because we believe that immunoassays and proteins offer a clear picture of the health. If you would now compare your body with a factory, then there's DNA, and DNA would be only a blueprint. So it would be only telling you what is intended to be built. But in contrary, the proteins and the metabolites with all their modifications, they really show you what is actually happening. And we believe that this is a better real-time picture of what's happening in your body. And then for us, that makes them much more accurate tool to monitor and to see what's going on in your body. So if you focus on proteins, there's a whole new opportunity because currently there are only 200 to 300 protein-based biomarkers that are used in clinical diagnostic. While if you look at blood, there are more than 10,000 proteins present. And especially the technological advances in the last decades, they really lead to the discovery of thousands of more protein biomarkers. However, the challenge here is that they are in the low concentration range. So if you would like to use this protein, then you have to have a technology that can measure very sensitive, that is properly possible to multiplexing, and that can be used in point of care settings. And we believe that our technology can do this. So if you look at the heart of our technology, it's a photonic biosensor. And you can see here in the left, it's our current chip, and it's dimension of 3 by 3.5 millimeter. And if you zoom in, you see that there are several spirals on the sensor. So the layout as a spiral was chosen because then you have a very long sensing area while having a small footprint. And the sensing area is actually a silicon nitride waveguide where we can send light through. You see also that there are several of these spirals on a chip, and this is because we choose for a self-referenced sensor design. That means that you always have a pair of two, and with this you can eliminate every matrix effect, which is kind of important for point of care, since you then measure in complex matrices like blood, plasma, or urine. We also developed in the past the material selective coating for these chips, and there we can use special coating to the silicon nitride waveguide that you can use to covalently immobilize the proteins you want to use for the detection, and the surrounding you can coat with a protein repellent nanocoating. And you can see in the middle on the picture that if we then immobilize fluorescently labeled protein, it will only immobilize on the sensing area, on the silicon nitride waveguide. And with this material selective coating, we can increase the sensitivity by a factor of 10 to 100. So all of this, the whole chip production, is compatible with the economy of scale, since it's all CMOS production. And we are also focusing on the wafer scale workflows so that the whole coating and biofunctionalization and the dicing is done on wafer scale level to be able to keep the costs low. So to the right, you see that now we have our silicon nitride waveguide, and when we send light through it, and there is a detection protein immobilized on it, which is here depicted as an antibody, and your biomarker or analyte you want to detect is binding. This specific binding causes a phase shift, and we can measure this phase shift with very high accuracy. So to show the capability of our technology, we developed a kind of showcase assay, a sepsis multiplex assay. And therefore, we used as a marker the interleukin 6, which is commonly used because it's raising very quickly in the sepsis. And we also used procalcitonin, which is an inflammation biomarker, especially for bacterial inflammations, and the C-reactive protein, which is also an inflammation marker that is more broad. So by combining these three markers, we measured them in 50% serum, and this could be a potential biomarker set that you can use for sepsis, which is not really simple to measure in point of care settings. Especially here, the challenge was that the three proteins, they span a wide dynamic concentration range in serum. So whereas the interleukin 6 is only present in the picogram concentration level, the CRP is in the microgram level. And we could show with this showcase that we could not only detect the sub-picogram concentration for ER6, but we could also measure the whole dynamic range up to the microgram per milliliter concentration that is interesting for the CRP. So, and if we compare ourselves now with what other point of care devices are on the market already, and we put them on a scale and look for sensitivity and the dynamic range they can measure for immunoassays, then we believe that we can be more sensitive, which means we can detect lower concentrations. We also look at the multiplex capacity the others have on the market, then we can do 5 biomarkers, which is superior to what is currently on the market. So we believe that our technology is really good. We have a few unique selling points. The multiplex capacity can be used for point of care, and we can reach high sensitivity. And these unique selling points are also successfully validated with top-tier diagnostic players and blind studies. So this is our technology, and now we are today interested in cancer. So we have actually 2 projects running that I would like to tell you a bit about that are focusing on cancer, even though our platform would be quite broad. So the first one is called Photix, and it's an acronym for Photonic Biosensor for Improved Colorectal Cancer Screening. And we work there together with the group of Professor Dr. Gerrit Meijer, who is an oncology expert, especially for colorectal cancer at the National Cancer Institute in Amsterdam. And here we are focusing on CRC, colorectal cancer, which have still 1.9 million cases worldwide each year. And it's still the second leading cause of cancer-related deaths. So the problem here is that it's often very silent. The diagnosis is quite late, and then we already heard that if the diagnosis is late, the outcome is worse. So here, the early detection would really save lives. The Dutch government started a CRC screening program, actually, that was fully efficient in 2019. And what they do is now they use the fecal immunochemical test, the FIT test that can measure one biomarker, hemoglobin in stool. So what they do, they send every person above the age or between the age of 55 and 75 this FIT test every 2 years. And most people actually use it. They send back a stool sample so far. I think 1.6 million, 70% of the people already read that. And then they will simply screen for blood or hemoglobin in the stool. And if there's no hemoglobin, you get a letter that everything is fine and you are invited, or you get this test again in 2 years. Whereas when they find blood, then they schedule colonoscopy appointment. And also, if you find something, they do histopathology testings there and will treat you. So since they used it in 2019, they actually find more people with stage 1 cancer of CRC. So that's very successful. So the group of Gerrit Meijer now identified a novel set of stool-based protein biomarkers, which they could link with high-risk colorectal adenomas. So they used healthy patients' stool from people that have CRC and from people that have this high-risk colorectal adenomas. They checked with mass spectroscopy what kind of biomarkers are specific, and they found several. And we are now currently using a few of them and develop assays for this. What is an adenoma? In your colon and rectal, you have normally small polyps, and this is a small growth in your inner lining of the colon or the rectum. And if it develops into an adenoma, that's actually a special type of this polyp, and it has different tissue, and 5% of them, they develop into an advanced adenoma, and they most time develop towards CRC. If you could now detect them in an early stage with this new set of biomarkers, you would be able to less invasively detect CRC. So that's why we are very interested in doing this, and we are currently busy with this. And to summarize, we want to develop a non-invasive test using the highly sensitive photonic biosensor we have. And we detect multiple biomarkers, so we do multiplexing to have a higher accuracy. And of course, our technology is able to do point-of-care testing, be fast, simple, and accessible. And that's why we joined this project, because you see that it matches with all our unique selling points. So we have a second project that is based on cancer, and we just had a kickoff of this. This is called YOLOphytis, and there the aim is to measure cortisol levels on demand. We worked there together with Professor Dr. Christian Planck, who is a medical oncologist and is expert in neoadjuvant immunotherapy, also situated at the Netherlands Cancer Institute in Amsterdam. And here we focus on adrenal gland insufficiency, which is also known as Addison disease. And this is actually a rare autoimmune system where your body produces too little cortisol. So cortisol is a stress hormone and is regulating stress, either mental stress or stress that is caused by injuries. And this is a common side effect that develops during cancer immunotherapy, and that's why Dr. Christian Planck is interested in it. It affects up to 140 people per million. And the problem is if an Addison crisis arises, so this is if either you have a huge stress or you miss your medication, then if it's untreated, it's even fatal. So, and also here there's a great need to improve the therapy, because if you have this Addison disease, then you need cortisol supplementation therapy for your whole life. And there, of course, the correct dosage is very critical, because if it's too low, you risk the crisis that I just mentioned. If it's too high, you get long-term damages. And if you look how the cortisol level look in a body, then yeah, it's quite diverse. And of course, if you are having stress, it will change. So here, it would be really nice to measure the accurate cortisol levels, so be able to really do the right dosage. And also here we see a nice fit with our technology, and we want to develop within this project cortisol assay, so that we can monitor it. Because if we would be able to have an early detection, then you can immediately treat and you can reduce the risk of the Addison crisis. You can also think in far future about like an online device similar to what we do nowadays with insulin, that you can directly measure it. So then you would enable the correct dosage for the patients. And because we can do multiplexing, we can combine this with stress parameters, because they influence the cortisol level quite a lot. So then this would improve the quality of life for the patients. And also here you see that we have a nice agreement with our unique selling points. And we were really happy to start this project. So with this, I'm at the end. Thanks for listening, and I'm happy to take questions.
Thank you so much, Dr. Anke Schütz-Trilling, for your impressive speech. I have to be honest, I'm very much moved by your presentation, because you said costs should never be a barrier for diagnostics. And this is such a strong statement for health equity. That's fantastic. I'm deeply moved. Thank you so much for this impressive presentation. So no questions from the audience. I have one question from a practical point of view. So you said you focus on proteins and metabolites. Most are low abundance biomarkers. So how does chronic, it's always the same question, how does chronic inflammation, you mentioned sepsis, but how does chronic inflammation interfere with cancer testing, especially with regard to routine testing? It's always the same question with regard to the background noise.
I don't get the question, sorry. By background noise?
Yes. Is there a significant interference with chronic inflammatory states and cancer detection in daily routine? I know it's possible to separate, but in daily clinical routine for daily use.
I think it depends how often you measure, so that you have for each patient the right level, which is quite different between the patients. So I guess then you have to sample more or do on a regular basis the measurements. And I think that, it depends on the biomarker and on the assays you have to use, I guess.
That's a great answer. So I'm a simple emergency physician, anesthesiologist. So we need a baseline somehow to assess a baseline for each individual patient. Thank you so much. That's a great answer for the daily use of these devices. Yeah, thank you so much.
Yeah. You're welcome.
So, Aurel is asking a question. How do you deal with non-specific bindings when you measure low biomarker concentrations in complex samples, such as blood? Thank you so much, Aurel, for your question.
Yeah, thanks. So first of all, we have this material selective coating that we have on the surrounding. So that means that we have on the surrounding, we have no loss of analytes, but also on the silicon nitride waveguide. I didn't mention this, but we have functionalities that you can use to specifically immobilize your molecule that you want to use as capture. And we have also some non-fouling moieties in there, in this polymer that we are using. So then we have hardly any non-specific binding. But however, we are measuring change of refractive index, and this you always have, and that's why we have this reference sensor system, two sensors that are coupled to each other. And if we measure unspecific binding that is caused by the matrix, then we can get rid of it by the reference sensor.
Thank you so much, Aurel, for this interesting question. Thank you so much, Dr. Anke Schütz-Trilling, for your impressive speech. So no other questions from the audience? Thank you so much. Thank you again.